Welcome to Curie Electronics. This is the second part of IPRC Technician B Electronics question paper solution. So first 30 questions we have completed. Let's solve the remaining questions. Question number 31. In a half-wave rectifier, the output frequency is. In a half-wave rectifier, equal to the output frequency is equal to the input frequency. So the answer is option A, that is F out. For a half wave frequency, F out equal to F in. F in. Question number 32. We have to find the resistance for the color code given. What is the color code? That is orange, violet, yellow, red and brown. So it's a how many band resistor is it? This one is a 5-band resistor. Now put the values. In a 5-band resistor, first three are for the digit. That is orange is 3, violet 7, yellow 4 and red is the multiplier 10 to the power 2. Brown, the tolerance band plus or minus 1%. So 374 multiplied by 10 to the power 2, which is equal to 37400 ohms. But all options are in kilo ohms. So if you divide by 1000, what do you get? 37.4 kilo ohm. And the tolerance we know. So the answer is 37.4 kilo ohm plus or minus 1%. Question number 33. A circuit which gives low output only when all inputs are high. First, let us consider the AND gate. For an AND gate, we know when all inputs are high, output is high. That is, A and B are the input, Y is the output. If you write the truth table now, what is the truth table? What we get? This is Y, 0, 0, 0, 1, 1, 0, 1, 1. So what is output? For an AND gate, when all of its inputs are high, we will get output as 1. Now if we take the complement of this, what you get? That is Y bar, 1, 1, 1, 0. Now what is the question? A circuit which gives low output only when all inputs are high. When all inputs are high, the output is low. Then it is, what is the gate? It's a NAND gate. That means to AND gate, we are connecting a NOT gate. So the answer is NAND gate. Option C is the right answer. Question number 34. Which light is fitted on the yellow light to produce green light in the traffic light control interface with 8051 microcontroller? This question I have not understood properly what it is, because if you mix red light and green light, we get yellow. And if you want from yellow, if you want red or green, we have to use a similar same either red color lens green color lens we have to use, but in the option it is not there. Or what and all, usually what and all colors are there in in a traffic controller, there are lenses are there. 3 lenses, that is red color lens, red color lens, green color lens, and yellow color lens. Those 3 lenses it is used. So this question I am leaving. I don't know actually. Question number 35. How many instructions are there in microcontroller family instruction set? For a 8051 microcontroller, there are 111 instructions. But they are not mentioned which microcontroller. For PIC microcontroller series, there are 45 instruction set controller and 49 instruction set controllers also. In PIC series, it is available. The device which protects the microcontroller from high current drawn by a DC motor is, the answer is opto-isolator. So we have a port pin. Let us take a port 2.0. So what we do, we will interface this with a optocoupler. And this optocoupler have a built-in transistor, and from the collector what you do, we will drive another transistor, and that transistor will control the DC motor. Which of the following statement is false for silicon transistor compared to germanium transistor? Silicon transistor leakage current is very small here, so this high leakage current, that is the wrong statement about the silicon transistor. In an LC oscillator, the frequency of oscillator is dash L or C. LC oscillator frequency is given by 1 upon 2 pi root LC. So these L and C are inversely and inside the square root. So the answer is option D is the right answer. Question number 39. In a FET, both junctions are reverse biased. When you use it as a amplifier, both junctions are reverse biased. Question number 30. The gain of an ideal oscillator. For an ideal oscillator, gain has to be unity. For a practical application, it has to be slightly greater than unity. Question number 41. RC differentiator will act as a simple differentiator. Means first we will have a capacitor, then we will have a resistor, and across the resistor we will take the output. So this will act as a high pass filter, because signal is coming, this capacitor will pass only high frequency, so it's a high pass filter. Question number 42. The ability of the receiver to tune in the desired frequency and reject the unwanted channel frequency is termed as selectivity of the channel. Fidelity means the clarity, the original sound, the ability of a receiver to reproduce the original sound, that is a fidelity. And sensitivity means the minimum signal required for the receiver to reproduce the sound or message. Question number 43. Amplitude modulation is. So in amplitude modulation, we will have a carrier wave. We will have a constant frequency carrier wave with the same amplitude. Okay. Then what we will do? When you mix a signal with this is a message signal, M of t. Then what we get? We will get a modulated signal. In that modulated signal, what happens? As per the modulating signal, the carrier amplitude changes. A similar kind of waveform we get. So the answer is change in amplitude of the carrier signal according to the modulating signal. Question number 44. In transistor, the point at which base current and collector current are maximum is called that is a saturation point. In saturation, what happens? We are turning on a transistor. We give a signal to the base, it will turn on, and this is connected to VCC. So whatever the collector current, that is limited by only by this resistor. Question number 45. Question number 45. 5 cells, each with EMF of 1.2 volt and internal resistance of 0.5 ohm are connected in series. The resulting battery will have. That means we have 5 cells. 2, 3, 4. We have 5 cells. 1, 2, 3, 4, 5 cells with the internal resistance. Then we have to find out what is the total internal resistance of the combination. And each are 1.2 volt and 0.5 ohm. So what is RT? RT of this combination, that is we have 5 resistors of 0.5 ohm. 0.5 ohm multiplied by 5. So we will get 2.5 ohm. Then what we have? We have a 1.2 volt multiplied by 5 cells. Series voltage will get added. So it is 6 volt. So the answer is 6 volt, an EMF of 6 volt and internal resistance of 2.5 ohms. Question number 46. If a 1 milliampere meter has a coil resistance of 100 ohm, then what value of multiplier resistor needed to measure 100 volt? I think it is 100. It is 100 only. Otherwise, as per that, please modify the answer. Let me solve it for 100 ohm. Now we have a ammeter. It has got a resistance. That is, what is ammeter resistance? 100 ohm. So it's a 1 milliamp ammeter. That means if you apply 1 milliamp to it, this is a meter. If you apply 1 milliamp through the meter, 1 milliamp, then you will get a full scale deflection. Full scale deflection we will get. Now what I will do, I know for full scale deflection 1 milliamps current should flow through this resistor. But I want to measure 100 volt. So what I will do, to make this a voltmeter, I will connect one more resistor in series with the meter. Now I am going to measure 100 volt. Now I know to get the full scale deflection for 100 volt, only 1 milliamp current should flow. So I know the circuit current. Now I will apply Ohm's law. V equal to, what we need R only we have to find. So we will write R is equal to V upon I. What is our R? R total circuit resistance equal R plus 100 ohm. I will write it in kilo ohm. That is 0.1 kilo ohm equal to, what is V? 100 volt. What is the current flowing? 1 milliamps. Now what do we have to do? I'll cross multiply. I'll write it on left side here. So I will get R plus 0.1 kilo ohm equal to 100. Now R equal to 100 minus 0.1. This is equal to 99.9. It is in kilo ohms. If I want to convert it into ohms, what I will do? 99.9 multiplied by 1000 99.9 multiplied by 1000. What I get? 99900. So option A is the right answer. Option A is the right answer. Question number 47. In the frequency spectrum, very high frequency band. Very high frequency band is from 30 megahertz to 300 megahertz. But in the option it is not given like that. So we can write 3 into 10 to the power 7 hertz to 3 into 10 to the power 8 hertz. 8 hertz. So the right answer is option A is the right answer. Question number 48. Convert 246 to the base 8 into decimal. Into decimal. So 246 octal we have to convert into decimal. So what do you do? Binary to decimal, how do you convert? Using the power method. So here we use the power method, that is 2 multiplied by 8 to the power 2 plus 4 multiplied by 8 to the power 1 plus 6 multiplied by 8 to the power 0. So 128 plus 32 plus 6. So 130, 166 decimal. So answer is option B is the right answer. What is the addition of binary numbers? So before that, 1 plus 0 equal to 1. All of you know. Then what about 1 plus 1? You will get 0 and carry 1. 1, 1, 1. What if you add what you get? You will get 1 and carry 1. Now let's write it and solve it. 1, 0, 1, 1, 0, 1 plus 0, 1, 2, 3, 4 ones and 0. Now let's add 1 plus 0, 1. 0 plus 1, 1. 1 plus 1, 0, carry 1. Now for 3 ones if you add, you will get 1, carry 1. So it is 0. We will get 1, 0. So it is 1, 0, 0, 1, 0, 1, 1 is the answer. So which is the option? 1, 0, 0, 1, 0, 1, 1. Option A is the right answer. Question number 50. Circuit having complexities of 5000 equivalent gates on a single chip falls under the category of large scale integration. That is, up to 12 gates we can say it is SSI, small scale integration. 12 to 100 it is MSI, medium scale integration. And 100 to I think it is 10,000, it is LSI. Above that, very large scale integration. 2's complement, we have to find the 2's complement of this number. So what is given? 1, 0, 1, 0, 1, 1, 0. Now we have 1, 0, 1, 0, 1, 1, 0. We have to take the 1's complement. 1's complement means we have to complement. This is 0, 1, 0, 1, 0, 0, 1. For 2's complement, we have to add 1 to this. So 1, 0, 1, 0, 1, 0, 1, 0. So 0, 1, 0, 1, 0, 1, 0. Option A is the right answer for this. Question number 52. What is the output frequency of full wave rectifier with input frequency of 50 Hz? For a full wave rectifier, F out is a ripple frequency. Okay, ripple is a ripple frequency we say is output frequency. 2 times the F in. So it is for 50 Hertz we should get 100 Hertz as the output frequency. Question number 53. Question number 53. The ohm meter reading for a short circuited capacitor is, if the capacitor is short circuited, our multimeter ohm meter will read 0. Question number 54. Which oscillator is used for generating low frequencies? This Wien bridge oscillator up to 20 kilohertz, that is the audio range. For audio range we use the Wien bridge, and here the answer is RC oscillator. It can give up to 10 megahertz frequencies. Question number 55. What is the pin number of reset RST in 8051 microcontroller? The right answer is option D. So ninth pin is the reset pin of the 8051 microcontroller. Full form of CISC, that is complex instruction set computer. Very simple direct questions. Question number 57. The characteristics of an alternating current is, what is the characteristic? With respect to time, its magnitude is always changing, and the direction also it changes periodically. So the answer is option A. Magnitude changes with time and reverses the direction periodically. Question number 58. The mean value of the alternating current for completing the full cycle will be. Completing the full cycle he has given. That means we have a full cycle. If you take the average value of this full cycle, it is going to be 0. For full cycle, okay, for full cycle, mean value equal to 0, average value also equal to 0. Average value also equal to 0 for a full cycle of AC. I not tick which it is. So the answer is, which is the answer? 0. Option B is the answer. Option B is the answer. Question number 59. The root mean square value of alternating current is equal to, once you know peak value, if you multiply by 1 upon root 2, you will get the RMS value, PRMS. So the answer is 1 by root 2 times the peak value. Option C is the right answer. And this is the last question. Find the capacitance value to charge 0.4 coulomb to have a voltage of 20 volt across the plate. So we can write it as Q equal to CV. What is charge? Charge is 0.4 coulomb. C we have to find. What is voltage? It is 20 volt. 20 volt. So C equals 4 upon 20, 0.4. Multiply numerator and denominator by 10, we will get 4, 200. So we can write it as 2 upon 100, that is equal to 0.02. So 0.02 farad is the right answer. So we have completed all the questions. One question, the traffic light question, I could not answer because I am not clear about it. And there was one more question regarding the peripheral device. That also I have doubt, because it could be mouse. As per the NIMI book, audio device, modem, printers, three of them are clearly given. It's a peripheral device. But this mouse also a peripheral device we can say, but it will normally call it as an input device. Then maybe the one of the mistake, I don't know. Let's see the answer key. I hope these videos are useful to you. If so, please share with your friends. and don't forget to hit the like button. And thanks for watching.